So Cynthia, I hope you tried the Facebook database. So as Collins is sharing his screen or finding a way to share the screen, you can go next by sharing what you try to accomplish. So we have like 2 minutes each. So Solomon, Catherine, and Vivian have already presented. So we're remaining with you and Collins. Just share your screen. Share your screen. The Facebook database, yeah. Yeah, just show us the number of tables you have. Just share your screen. You show us the number of tables you have, you created, and then we you explain what you did, and then we go. Pardon? Yeah, the database, Facebook database, and all the tables. We want to see and how many tables, and also show us an example of a table description that you have. Present, it's this icon name. This one. Yeah. So Cynthia, are you there?
Yes.
Yes, you can share your screen and also show us what you try to do in the Facebook database.
Okay, let me try.
Collins has shared. So after Collins, you'll present. So yeah.
So the first thing is the Facebook database, which is that. And in Facebook database, the first table was the account. That's my initial.
So let's see all the tables you have.
Nothing is happening here. These are the tables I have. Account, credit card, profile. And,
Let's see what is inside the profile table.
Profile.
Okay. So that was the profile table, Kweli?
That was not a profile table. I realized there was a business under. It was basic information. This hii like a chat table for profile table. Unaona profile ndio hiyo, then basic information iko na kuna other columns na si kuweka. So we made a mistake kuchukua basic information, contact information, everything as part of our profile column. Which you don't know when it's supposed to be right.
Okay.
Then the problem was now that you have this credit table on your account, how do you merge it together? And account was one, then our profile, and credit card, get my events. How do you manage it together so that you could you keep in that database on Facebook, then on profile. So that's where I have the problem.
Okay. So thank you. We shall revisit that. Now, Cynthia, you're up next. Cynthia, are you there?
Can you see my screen?
Yes, we can see it.
Okay. So I've actually finished. Guys, I have closed the work by mistake. Oh God. I have closed the work just by mistake.
So just don't be in a hurry. Don't be in a hurry. You're typing the password you're typing the username instead of the password. So we'll be patient with you.
Okay. So I created my database, Facebook. Facebook.
So, Cynthia,
Yes.
we just want to see what already you've done. So you can see it already exists. So we just want to see what you already have done. So just show us the Facebook database and also the details. Yeah.
There's an error.
So the command to show the database is /l.
Oh, /l. Okay.
Okay. Then now show us what the Facebook DB has.
What? Attention, what?
What Facebook database has?
So what have I shown? I thought I've shown the database.
You've shown the databases. I want to see how many tables Facebook DB has. Did you do that?
Yeah, I did.
You didn't do it, okay?
I did.
Okay, Jen, then show us.
Am I supposed to list the tables or list like the database itself?
Connect with Facebook database /C Facebook.
Uh, yeah. Um,
Then list the tables inside there.
okay. Um, I list all the tables. All
Yeah,
the
the tables, yeah.
okay. My first table was
Just
account.
slash D. Don't, I want to see how many tables you have. Okay, so thank you, Solomon.
13. There are 13 tables.
Okay. Did you add any columns inside?
No, I didn't. I didn't have any problem inserting the data into the tables.
No, no, not inserting the data.
Mm-hmm.
Do you describe your tables? Did you have a column definition or maybe table definition where it has columns inside? Like, let's see the accounts table. What does it have?
Okay. Uh,
Okay. So that's it. So thank you for that. So I think we'll stop at that point. Okay. So the Facebook database is not over. We will always. Oh, that is just the beginning of the Facebook database structure. We haven't added any constraints. We haven't added any data inside. So we still have a long way to go. So I'll expect also for those who didn't try, you try then on Thursday or maybe by Thursday you have covered the same ground as those who have tried as we go on. So today we are going on. So remember we were in table definition. No, database manipulation. No, table manipulation. I mean. So we finished the database manipulation. Now we are currently in the table manipulation, and that is what we want to cover today. How do you manipulate your table? Or how do you continue manipulating your table? Because what we did so far is creating tables, adding columns inside. We haven't updated our tables because that is what I expect us to do today. I want us to, I think we added columns inside, right?
Then it got
Yeah, we added a new column. So after the column, after the table definition, you can add column. So there it's where we stopped. So today I want us to continue and I want us to cover some good ground also when it comes to table manipulation. Uh, and I want us to speak about constraints. So that is what I want us to speak about, constraints. So let me just retrieve the Google documents that we had so that I can also, or maybe I can share just I can just share the PSQL so that you don't also see I'm typing. So that this is what I'll be sharing. I'll be sharing with us. So I'll extend my screen so that you can follow the notes later as we continue. But I'll be only be sharing the. Anyway, let me just share everything for now, so that it at least you see everything. Okay. So we'll cover the constraint, and when we spoke about table manipulation, we spoke about column definitions, and we said that. So let me open my notepad. We said that when we're speaking about column definition, so the syntax of creating a table, I'm sure all of us we know because we have created those tables 20 something times, 21 times. So we are not going to repeat the syntax of creating a table. But now I'll just go inside and now speak about column definition. So we said we begin with the column name, okay? Then the data type. We said this is where we had reached. This is what we had covered so far. So let me just do it. Get table student. Then we are adding a column name, and then we close. This is what we had covered. But remember, I told you that the additional things that we always do when declaring column, when we are defining a column. The first one is the column name. Then the next one is the data type. Now we want to add up two more things here, or maybe a few more things here that are called constraints. Okay? So we'll speak about today about constraints. What are constraints? Okay? So constraints are just rules. They're just rules that govern the behavior or maybe the data that comes in when it comes to adding records inside a table. So by you defining this way a column, it is complete, it will work perfectly. Okay, but now the problem is you haven't narrowed it down so that you specify to the user of the database what kind of data you want. Because if I just say name, let me use this column, an example of a column, name, and I say Pacha. Okay, this column definition is so ambiguous. So it's always advisable that we narrow it down to a specific type of data we want to store inside the database. So you just don't leave it that ambiguous, but now you narrow it down. And what helps us narrow it down is one, you specify the size of the data that column is going, or maybe that cell is going to hold. So you specify the size, and also you add a few constraints. So what you're going to add here is one, size of the data. And number two, constraints. An example is this. When I say name, when I say I want to store name, when I say I want to store name, I can just say name, character varying. Then inside here, I specify it's going to have to be of length 20. So it means it's going to store 20 characters inside, including spaces. Okay, so when I specify that, I'm specifying one, I'm not creating a database that is of huge size. Every single cell has a specific size. Okay, so you specify the length, and also once you have specified the length, you also specify constraints. Now, what are constraints? Constraints, I've just told you, there are rules, okay? And there are several types of constraints. So constraint number one, it is called primary key. Number two, it is called foreign key. Number three, we have a constraint unique. We have a constraint not null. Okay. So these are the four, I think I'll add you as we go on. So these are the four main constraints that we always use. We have another one called index. So these are the few constraints that we always use when it comes to specifying or maybe defining a column. So we are going to see when and how you use all these constraints.
Hello. Hi. Oh, poa, nilikuwa nafikiri uko class unipe the link but
So
nimekuta.
Cynthia, you can mute a little bit. So Cynthia, you can mute.
Huh?
Okay. You can mute. Just mute.
Oh,
Yeah.
yes, yes.
So these are the constraints that this is now the last step when it comes to column definition. So we begin with the name of the column or the column title. Number two, we specify which data type it holds or data of which type. Number three, we specify the length, but now here I haven't completed it yet. So you specify the length. And number four, you add a number of constraints. So I'll just say con one, con two, con three. Let me use these three dots. Now it means that a column can have more than one constraint. Okay? Now what are these constraints? So I'll begin with the one that we know, unique. When I specify unique, I mean if I have records inside an Excel sheet, an example is this. If I have records inside an Excel sheet, a column like telephone number, for all the records I hold, they need not to be the same. They should never be the same. Every single person has their own unique telephone number. Okay? So that is what unique means. So the telephone number for Jacob should never be the same telephone number for Edward. Another example is for ID number. Every single human being has their own ID number. Okay? It should never ever be the same. So that is what we mean by unique. Okay? Just as the name suggests. So it specifies that you hold data of different data. So data should never be the same inside that specific column. Okay. Not null. We know about nullability. So null means empty. Okay. So when I specify not null, it means a value must be passed. Let me say stored. When I say not null, an example is this. If I'm using the same data points, first name, every single human being has a name. Okay? The name can be the same. We can share names, but there is no human being who has no name. So that means that in this case, I'll specify that first name is not null. Second name is not null. The other name can be null because there are some people who have only two names. Okay? So in this case, when you specify not null, here we can also say or null. Whereby when you define a column, you can either say it's a not null column or it's a null column. Okay? Now, So what is, so I'll go then to the primary key.
So, excuse me.
Yes, please. Yes, Solomon.
Yeah. Okay. So I was asking. So, is it possible now to say, for example, maybe first name, you put now the data type, then you say not null, and also you say null.
Now, for that case, it's not
Oh, that is
possible.
not what it means.
Okay. Now, the reason why I've said not null and null in the same line is because of this. By default, when you define a column, the constraint that comes with it is null.
Okay.
Okay? Whereby, if you don't specify not null, by default, it comes with a null value. The reason being, they assume that for you to have a total command over your columns, then you must tell it what, first, the data type it holds, number two, the constraint it has. Okay, so the not null, so this null, it's, I've just placed here, it's not supposed to be here, by the way, because all columns come with a null constraint, though it is not being shown as null, but they come with a null, so it can be empty. But the moment you specify not null, it means that entire column must be filled by data. Is that clear?
Yeah, very clear. Thank you.
Okay. So let me move this up here. The reason why I began with this, you'll now, so these are the constraints that we have: unique, not null. Now I'll go to primary key and foreign key. Okay. Now, I'm sure all of us have gone through an academic system. And when you join, maybe you're given an ID, school ID. Okay. So in school, they don't identify you with a name. They identify you with a specific ID, which is the school ID. In Kenya, as long as you're 18 years and above, they don't identify you with a name. They identify you with a national ID number or maybe a passport number. Okay? So it means this is a special key that one uniquely identifies every single record inside your table. Okay? So it uniquely identifies records inside your table. But remember also, we have a unique constraint, which also uniquely identifies records inside a column. Okay? So when you speak about unique, I'm uniquely identifying records inside that column, one. And that is the only thing unique does for you. But when I speak about primary key, it means that one, I'm uniquely identifying records inside the entire database. Okay, so that when I use that field, or maybe that key, which is the primary key, I'm uniquely identifying the entire database, not only now a column, now the entire database. But also you can use unique to get records of the entire records of the entire column, okay, or maybe row. So I'll just show you this using the Excel sheet, but I want us to understand first in the theoretical side. So when I speak about primary key, now a primary key, it's a bit special because it is a combination of these two keys, unique and not null. So it combines the two. So when I speak about primary key, so we can just do here don't know what I can do. I wanted to create a table. So let me just say this primary key, and then here I say unique. For primary key, it's a combination of unique key plus not null. So let's state the differences so that we at least know. So it's a combination of unique and not null. So this means that if you define a column unique, it means that that column can be null. Okay? That is why we have both of them separate. So when I say a column is unique, one, it means it should not hold records that are the same, ever. Okay? But that column can hold it's not a must, it holds data. So it can be null. So it can be null, but in case you pass in a record, it must be unique in the entire column. Okay? So let's do an example of unique here.
Maybe a question.
Yes.
So does it now mean that null, maybe when I have values of null, maybe 1, is null itself not unique?
Nice question. So when I say unique, I mean,
I don't know if you are getting my.
Yes, I think I've gotten your question. Let me try and answer it, and you tell me if that is what you mean. So when I say unique, I mean, if you don't pass me a record, I'll not check for its unique ability or something like that. Okay? So if you don't pass me a record, I'll just say that you didn't pass me a record. So I'll not check if it's unique or not. Because you didn't give me something to check against. Okay? Until you give me something to check against, it's when I'll check. This record you have given me, is it unique in the entire column? But if you gave me a record, if you didn't give me a record, I'll not check if it's unique or not. So I'll just leave it that way. Okay? So unique applies only if you pass in a record. That is what we have said. That is why I've said that when you give me unique, it can hold null values, and it can also hold records that only appear once in the entire column. So is that clear, Solomon? Solomon.
Yes, I've now noted the difference. You have answered the question. Thank you.
Okay. So anyone else?
Can you hear me?
Yes, I can hear you. So anyone else with a question? Anyone who thinks about unique, they haven't gotten it correctly before I move to primary key. So let's just try to internalize this unique so that when you move to primary key, it does not bring any confusion, because it always a bit confusing, the unique and the primary key. Catherine, you okay?
Yes, I am.
Okay. Okay. So that is what unique holds. So one, it can be null. Number two, it should not be the same in the entire column. So it only checks its uniqueness, the data uniqueness, only if you pass in a record. So if you don't pass in a record, it will not check if it's unique. So don't confuse about null. Yes, null, when you have null in the entire column, it means two nulls are not unique. Okay, but now it checks only if you pass in a record. So that is what unique does. An example is this, even in the cell phone. here. So when I say unique, it means that I can have someone who doesn't have a phone number, a telephone number. I can have people who don't have telephone numbers. Okay? So it means I'll not come here and say not null. Because based on the context I am in, the data I'm collecting are for guys who might not have telephone numbers. So I'll not confine someone to give me a telephone number and they don't have it. So that is where now you apply in unique, whereby you only use unique and you still allow it to be null. Okay? Now, for primary key, it's something like this. And I think this one we have always used it several times. ID. When I say one, when I say 1, 2, 3, 4, 5, hata iko hapa, sijui hata mbona na type. It's here. This one. In an Excel sheet, you'll never see column number 1, ati hii ni number 1 tena kuna number 1 ingine hapa. You'll never see that happening. Okay? Whereby even if I delete this row number 4 imepotea. But now Excel will replace na 5. Okay, so the numbering here, this sheet, it will forever be unique even if you delete a cell. Also, when I came to this listing of my IDs, 4 was deleted, but now I have 5. So 3, 5. So it means that someone deleted record number 4. So that key no longer exists. Okay, and that is how you know if you're doing some forensics on maybe you are checking again your data, you'll come and realize that probably there is someone who deleted a record here. Now you begin now to investigate who deleted it and why did they delete, because in data, when it comes to data, there is we don't use delete. Never ever use a delete button when it comes to data. Okay? We can only update a record, but we can never delete. We shall speak about that as we go on. I'll tell you more about that as we go on, okay? So this is the unique key. Now this means that when I speak about ID, 1, it must be unique, and number 2, it should never be null. Okay, so the primary key holds 2 constraints. That was why I said the primary key is a bit a special key, because inside it has 2 constraints. So though you define a column as a primary key, but in the back, whatever is being executed, there are 2 constraints. Number 1, it is unique, and number 2, it is not null. Okay, so you will never have a primary key. Let me just do this. Oh, I forgotten. So let me say 6, 7. Well, I've forgotten, sorry. So here, so I have an example here. I have an example of past names here. There is no any single day that you'll realize if you have a record that is appearing like this. As long as you have specified that the ID is the primary key, there is no any single day that you'll have a record appearing like this. Never. The reason being is this: for a record, for a column to be a primary key, it must satisfy those two things: unique and not null. For a record to be a unique, for a column to be unique, it only needs to satisfy one thing: unique. But for primary key, two things: unique and not null. Okay? So that is the biggest difference between unique key and primary key, whereby the primary key is both and the unique key is only applying on one constraint. Is that clear? Okay. Anyone who has not gotten it, I better spend the entire week here kwa hii vitu ya constraint rather than rushing, because it's a very fundamental thing. Anyone with a question? Okay, cool. So that is what a unique key means. Okay, so that is what unique and foreign key means. So we shall do it in practical, so no worries about it. We shall do it in practical. So that is the difference. This one can be unique and null. So this one is unique and not null. Okay. Now, in some special cases, an example like this one, let me just mention that before we move on to the foreign key. An example like this one, okay, when we speak about unique, a primary key, the next key will always be 8. The next key will always be 9, 10. So it will always increment by 1. That means that there is something called auto increment. So when you speak about primary key, there is an attribute called auto increment. Auto increment. Now this is not a constraint. This is not a constraint. Okay? I always label it as a flag. Okay? When deploying something. Like just the way we always deploy vaccines, or maybe we flag it out. So in this case, I always refer to it as a flag, whereby it is an additional thing to a primary key. So this auto increment can apply to any of the columns as long as it is an integer. Okay, so if your primary key holds data that always auto increment by 1, so you always add that flag auto increment. We shall see that in a practical way, but in Postgres it's a bit different. Okay, so I'll just tell you how. So that is what, let me just put that clearly before we go on. Now, the next constraint is the foreign key. Now, what is the foreign key? A foreign key only comes into existence if there is a primary key. So let me just say uniquely identifies records inside the DB, the table. Okay, now when we speak about foreign key, in simple terms, it's a primary key of a parent table. That is what a foreign key is all about. It's a primary key of a parent table. Okay? Now, I've told you, for a foreign key to exist, there must be a primary key. Okay? So, a table can have these two keys inside it, a primary key and a foreign key. Now, an example is this. All of us, I think we have Is it surname or biological name? What is it called?
Son.
The surname. No, surname is yours.
Maybe
Family name or something. Okay. So an example is this. I know all of us might have three names. One is your first name, then your surname, and then the other name. I don't know. I think I've forgotten what is. Is it biological name or something? Which you get from your parent. Okay? Anyone who has here three names. We can use an example here, Vivian. Vivian, I think there is a name here yenye si yako. It's your parents' name. Sindio?
Yes.
Which is?
Osiende.
Okay. So Vivian and Bosiwori are your names. But Osinde is a name that you inherited from your parent. So your parent had a primary key, had a primary name, which is, now Osinde is his primary name. So to him, it is a surname. So when he's being, or he or she is being addressed, they are addressed by that name. Okay? But when it comes to you, you hold that name, but you are addressed by maybe Bosibori. Okay? Because that is your surname. But you hold your parents' name so that that lineage can go on. Okay? Probably your child will not hold that name, but they will hold now Bosibori if possible. So you see how foreign keys also apply when it comes to how they try to get foreign keys from real life scenario or maybe human being scenario into now the database. Whereby your family name is the surname of your parent. And that is the primary key of your parent. So they always address them with that name. Okay? So that lineage or maybe that structure, that tree structure is what we refer to as a primary key, a foreign key. It is a primary key of a parent table. So in this case, let's use the surnames. So your parent's surname is your other name. Your surname will be your child's other name. So in this case, your surname is what people always address us with in most cases. When you go to offices, they begin with that name. Okay? So it means, and I think here the HR in the call can attest to that, whereby they always refer to you using your surname more than your first name. Mr. Someone, Miss Someone, okay? So that is what uniquely we can apply to as the primary key. But when it comes to the foreign key, it's now what your child inherits from you. Okay? And that is what points you back to the parent. So that is what foreign keys means. So they point us back to the parent record, and also the parent record can point to it and say, these are my children. You can have two parents. In this case, you can have, okay, 2 are 1. 2 are 1, yes. As long as you're together, you're 1. So that's what it always applies. So when we come to that scenario, it means you can have one parent. They contributed to bringing you on up, but you can't have more than 2 parents. So in this case, your parent can have many children. Okay? Your parent can have many children, but one child cannot have many parents. In the context of biological parents, let's say like 5 biological parents, okay? So we are going to that level as we go on. So that is a class for Thursday, where we'll speak about more about these relationships as we wind up our classes. So you can see that context. Okay, so a primary key uniquely identifies a record inside the table. Number 2, a foreign key, it's a primary key inside the parent table. So it means that you have child table. Now, when you're speaking about a foreign key, you are standing inside a child table. Like you are a foreign key to your parent. Sindio? Ha. Okay, I've tried to explain that in more layman terms, and I think anyone who has not understood this,
Um,
be honest, okay?
so maybe a question.
Yes.
So does it now directly mean now in the context of maybe the parent and the child,
Mm.
the parent is the primary key and the child is the foreign key?
No, the parent, it's the parent table. Okay, a parent, remember when we are using names, we are not using human beings, we are using names.
Ah,
Nakumbuka hiyo, we were using names of people. So when we are speaking about the parent table, it's different from name inside that table or a column inside that table. So when we speak about a primary key, we are referring to a column inside that table. That is why we are using a name of a person. We are not using the entire human being. So this name, in the context of DB, it can be a column. And that column, when you are defining it, you said this column, it's a primary key. So when you create another table, you realize that you still need that column which was inside another table. Now you specify it is a foreign key. So tables are referred to as a parent table and a child table. That is why I had this, a parent table. Okay, but now you're pointing to several records inside a child table. You're pointing to several records, okay? So no worries about that, okay? So we shall just go back to it on Thursday, but you can still refer to, maybe just internalize on it. So this foreign keys and primary keys, we shall go in depth on Thursday with them, on them. But now, today, just know how they work. Try to think and see how what I've tried to bring on board. Even a good example is what I've just told you. Your parent and you as a child, whereby you take their name and your name you'll pass to your child. Your child's surname will be the surname of your grandchild. Okay, so we use names. So when you're speaking about names, you're pointing to a name. Sawa. That one it will help us to understand Thursday class better. Now we have the final one, not the final one. We have others, but let's settle on this. The index. In most cases, you'll never use it. In most cases, the index. Now the index just help you to search records easily. Okay, so when you specify an index, if you have a billion records and you didn't give it an index, it will take more time to search records inside the database compared to when you say index true. Sawa. So index is just a matter of helping you to search records very fast. Now let's do a practical way. Now let me finish with this. First of all, the size. The size. Okay. I wish I could give an example of this but now because we have guys who didn't do Python, I'll not give that example. But if all of us could have done Python, there is a way where we say there are data types that are of a sequence nature. Okay? We say data types that are of a sequence nature. But since we haven't done Python, we only specify size if that data is string.
What do you mean of a sequence?
Yeah? So, acha niulize hii swali. Kuna mtu ameniuliza hii swali. So let me ask Catherine and Cynthia, I excuse you in this because you didn't do Python. But now Vivian, Solomon, and Collins. What are data types of sequence nature in Python? We were beginning on loops, so I think we did loops, or maybe we were beginning on that. So I expect us to know data types of sequence nature.
I think it is list, tuple, and the range.
Yeah. Okay. These are data types that you can pick one element at a time. Let me just use that for the sake of guys who are new in Python, whereby you see in a computer memory. I didn't want to go into this, but let me just help you understand for the sake of Catherine and Cynthia. If I say x equals 10,000, and if I say name equals Catherine, if I say this and this, when it's being stored in my computer, x equal this value, it's stored as one object. Okay? Inaenda kuwa stored hivyo once, pap. 100,000, 1 million, it is stored that way. But when I say name equals Catherine, how it's being stored, inakuwa stored one element at a time. C, A, T, H, they are being stored individually. Okay? Ni kama kucheza ile game ya kupanga mbao. What is it called? Inaitwaje tusaidia, ndio najua. There is a game I think I've seen people play, or maybe if you have played, you're one of the people who have played, whereby you arrange wood as you go on top of the other. Hivyo. Sijui kama umeiona. Sitaki kuisearch hapa, ingetokea. But that is an example, okay, where you store as you go. Okay, so you store one element at a time. And also you can access C, you can access A differently. Okay, and now it's called using indexing. Now this is indexing. So Cynthia and Catherine, when we do Python, you shall now understand this logic better. But now when it store x equals 10 million, kwa database inakuwa stored hivyo once, pap, 10 million. But when you store name equals Catherine, every character is being stored on its own. Okay? So kuna some small partitions in that memory location called name that stores each character on its own. So you only specify length when it comes to data types of this kind of nature that can store C on its own, A on its own, things like that. Because siwezi sema that X, this one I specify it as a length of 30. No. Because it's being stored as one element, one object. So when I specify length here, I'm specifying this data. Sawa. Yep. So usiende kwa integer na useme integer alafu hapo ndani una specify size. It will give you an error. So let's begin with okay. Anyone with a question? SQL. Anyone with a question? So let's begin by kwanza. Hopefully you can, things on my side a bit bigger. sawa, tuko sawa. Okay, so let's create a table. Sijui ni database gani tuko nayo hapa. Database /L. Oh yeah, we did a school DB, so let's connect to school DB. Cool. So when I describe it, I only have one table for my case, but I'm sure you guys, you had several relations. So you have more than one relation. So yep. What other relation do we create now? I have students, I have teachers. Do we have teachers, right? Yes, we have teachers. We have subject, we have marks. Any other relation? In a school environment, someone to give us a suggestion. Let's use yes, please.
Support staff.
Lab technologies.
Hey. Sasa hii hata tutajua columns ni gani? Tupe columns basi, tupe columns zenye tutaunda. For your tables zenye umesema, which columns do you have?
We create support staff, then niotweke hizo ma lab technology, nurses, cooks.
Okay, so let's create a table support staff. Teachers are not staff.
Teachers are staff. But now support staff in this case, announcement.
So we have staff. And let's begin with the first column ID. ID, so it's an integer. So we have an ID. So the data type of an ID period. So that is why I told you both places are different. So hapa ndio hapa ndio tunaanza sasa kuchanganyikiwa kidogo. So now so wacha tufanye hivi. Just do integer. and then say serial. Let's try, not in caps, if you're doing small letters.
Netflix content.
And let's do name, and we say Vacha. We give it a length of 30, and we say not null. So we are evoking a few constraints that we want to use, okay? Then let's say telephone number. Telephone number. The telephone number is it a string or an integer? Okay. Integer. And we say unique. Kwenye tuchukua na hizo tatu ndio tukipata error solve kwanza. Nimepata error. Okay, so this is what I wanted us to see. So the first instance, you must get an error. Serial. And remember, I told you that when people try to create their databases or database management system, they try to do their own, what is it called? Their own way of making it simple based on their context. So in this case, support staff as an ID, but we are just doing one thing, which is the serial. Now a serial, it's a package on its own. So a serial holds this. It's a primary key, it's a unique key, it's a not null key, and number 4, it's an auto increment. So in Postgres, when you say serial, you're saying primary key, not null, unique, auto increment. That is what you say when you say serial, okay? So nani amepigwa na error bado? Nataka tukue tumepita hapa. Who has received an error package?
Okay. I have.
Catherine, what error do you have?
Just a minute. Syntax error at or near serial.
Near?
At or near serial.
So you have this error, syntax error at near serial. So what you do, you
Yeah.
remove the integer. We remove the integer.
Okay.
Yeah, so when you define your column, you just say create table support staff, ID serial, name, varchar 30, not null, telephone number, it's an integer without a length, and you say unique, and then you close the bracket and have a semicolon.
Okay.
Yes. So Solomon,
Yes, sir.
umepata hiyo?
Yeah, I got a syntax error.
Yes.
Yeah,
But you have
but
solved
I'm
it.
doing a correction. Yeah.
Okay. So Vivian,
I got an error, but I already fixed it.
so it has worked.
Yeah.
Okay. So Cynthia,
I also got a syntax error the first time, but I have solved it.
okay. So So I just wanted the reason why is I deliberately did that right because so that we know when you're defining serial you don't need to pass the integer. So yeah. So when you do edit, so for those who have completed, you can do that /d on the support tab.
Leon, I have a question.
Yes.
If I want to move from, let's say, like right now we're on the school database and I want to move to the Facebook database, what do I do?
You just do /c. Then you type the database name.
Okay.
So I want us to finish at some point when we have inserted records inside our database. So that's why we'll stop in creating records inside the database, and then we shall stop our class. Catherine, I don't know if you have already created it.
Come again, created?
That table with the serial.
Yes, I have.
Oh,
Yes,
okay.
I have.
Okay. So I think we can go on. So when you do a /d, then the support stuff, this is what you see. So this is what you're going to see. Now, if you do a /d, it's a bit different from if you do a /d. What was the other tables on student? /d, if I just do /d students, I don't have any column. Okay, so it's a bit different. I know for those who have at least other columns, they'll attest that, whereby it's a bit different because for that case, we only had column and type, nothing else. But right now you can see we have an additional 3 columns, whereby we have the nullable column, which is already added, and field, which is not null. And we also have a default value. Okay, but also when you look at the bottom, there is something called indexes. And when we speak about indexes, it gives us an index. So it's like a list of all constraints, additional constraints in columns. And for this case, you can see we have a support staff telephone number key. So this key applies to this telephone number. And remember, when we say telephone number, we say unique. So it says that on this key, we are applying a unique constraint. So. So that is how you see the constraints that have been applied on your database. Okay. So hopefully that is clear. That is clear when it comes to that. Now, how do you insert records? So let's finish with that. So I'll expect you to update. We learned about updating columns. We learned. So I want you as a task. For those who have already created the Facebook database, it's a bit hectic now. It's going to be a bit hectic in the sense that for all those columns that you have, I want you to add a constraint, which is not null, a not null constraint. Niko sure hapo mtu ameshangaa, si ndio? That is a bit heavy, right? So we want us to add that constraint up on the note on all the columns that we have. But in the meantime, let's do an insert. So how do you insert records inside your table? So I shall show you how to do bulk. Let me just search it here. There is something called Mokaru. What was it? I think that is it. So there is something called Mokaru, this one. Can I share with you on the chat? In your free time, you'll this is what you. So this is what we are going to, so this is what you're going to learn, how to add records into your database. So there is something called Mokaru that will give us an idea of how to add records. Whereby for the table you have, you can see first name, last name, email, gender, IP address, and things like that. So you can come here and add a field and say page. You can add a field, you say, oh, what is it? Oh, so you can also say that it's blank. So you can see there are some data types here that apply. You can add gender. Okay. So there you can add as many fields as you want. So it's just a way to help us pull a lot of records directly into our database. So you can download it, you can download that data, you can preview, you can do that, all those stuffs that are here. So I'll show you on Thursday how to pull a lot of records from your data to your database. Now, how do you insert records into your database? So we want to do a few records. So for this case, we want to use the support stuff. Now, so to add records, you just say insert into support stuff. Insert into support stuff. It depends on the way you declared your table. Me, I'm using mine into support stuff. Insert into, wow, I have a meeting at 8. Insert into support stuff. Then you say name and telephone number. Now remember, we have skipped the ID because we say the ID is going to auto increment. So then insert into support staff, name, telephone number, and you specify values. Now you add there your name. That's the case. Then telephone number. So that is how you insert records into your database. So insert into support staff. So insert into what table are you inserting in? So you're inserting into support staff table. Which columns are you adding in data? And you're adding into 2 columns, name and telephone number. What values are you passing? So if you say your name is a string, make sure you put it inside quotation marks. So values, test case, comma, and the telephone number. I'll repeat it again. So insert into telephone number, values, video tutacheka. So that is how you insert into your telephone number, into your database. Ndipo tuko sawa. Insert records ni rahisi, si ndio? It's a bit.
So maybe a question.
Yes. Yes, please. Go on.
So when we say insert to, so it means now we are giving the values now into that element that we created called
Yes.
support stuff. Now For example, I'm listing maybe the names of the support staff and the phone number.
Yep. So what you
And
do?
also, does it mean now maybe
Yeah.
when we are doing other one, we also still use the same thing, insert into?
Yes. You use insert into, but you can do bulk inserts. That is what I want you to try in your own free time.
Okay.
I have 100 records. I'll not type one insert 100 times. I want you to try and help me. How do I insert 100 records once? So. Okay, so that is how you insert. So how do you get records from your database? So, and that is why we are going to stop. So getting records from the database, we use select. Select all from support staff. Yeah, that is asterisk. So select asterisk from support staff. And you'll realize that the ID ilitujazia yenyewe, si ndio? So that is where now auto increment comes in. Nakumbuka vile nilikuwa nasema auto increment. So serial, it's a matter of one, auto increment, nini, hizo vitu zote ukiziweka pamoja ina form that. So I think we are stopping at that point, unless someone has a question. So I expect you, the last thing you tried is to select all from support staff.
Maybe a question.
Yes.
Now from that we have talked about maybe a single column. So maybe is there any way that maybe I can select maybe from maybe several columns, not only one?
That you can? Just repeat.
Then I can is there a way that I can maybe select from 2 columns or maybe 3 columns?
Yes, there is a way. You see the way we have said insert into. You see here where we have said insert into, then we specified the columns you want to insert into. We can also do that for select, whereby you say select. But I wanted to cover this now to continue with the select part on Thursday. But because you have asked, I think I can just do that. So you can say select, and you specify which columns you want to select, and you say name. Let me say ID, and name. So you can specify that. Then you say from support staff. And you'll get ID and name without telephone number. So you can always work our way around that. But now in depth, we shall cover that on Thursday, on the select and the insert.
Okay, thank you.
So any question, Catherine?
No, good.
Cynthia? Okay, so I think you're stopping at that point. That information was so much to comprehend. It will take you a few more days to, if you keep on practicing, it will take you a few more days. And because you haven't, this is the first time maybe you're encountering constraints and all that stuff. So there is a lot you can do in constraints. So, but now for now, we shall just try to use what you already have, because constraint it's so wide, very, very wide. There's something called relationships, which we shall finish on Thursday, and other things. Okay, so it is so wide, but we shall try. I've tried my best to make it a bit more in English and use things that you can relate with more. Okay, so hopefully it didn't sound a bit more of tech, but it sounded more of now things that you can relate with. So I think we are going to stop at that point. But in case of any queries, maybe in the course of in the next 2 days, you can always reach me out directly, and I always help. So don't die on your own. So. So try and improve the Facebook database. Add constraint. Add at least one constraint to all the columns. Okay. Add at least one constraint, and maybe try and add data in it. Just try, do your own things there. I'll show you a simple way yenye utaanza kuniambia that I wish tungeanza na hiyo, which is the PG admin. But now the reason why I'm preserving the PG admin as the last thing is so that you can appreciate what happens on the back end. And also when you go to the market, maybe someone gives you a database, they might not give you PG admin or maybe the interface, because data is being stored in their servers, and their servers, they don't have those interfaces. So you'll have to interact with the PSQL or maybe a shell. If not PSQL, PSQL ya MySQL, PSQL ya Oracle, hivyo. Okay, so you'll have to interact with that. You'll have to know to connect to the database using MySQL. How do I select directly from the database? How do I delete? How do I update and all that? So we have 2 more days to conclude on SQL. So Thursday and Friday. I asked you guys, in case you have a database in mind that you want to create, you could have raised it out, but I think all of us are comfortable now. Probably you will have to create those databases on your own. So other than that, I think we are stopping at that point. So have a fruitful 2 days that are coming.
Thank you.
Okay. Bye.
Good night.
Good night.
Good night.
Collins.